Is there any question related to what we have learned yesterday or day before yesterday? So today we are going to discuss about a circuit that can perform addition and subtraction based on our control command. So as you can see, this is our circuit. So what I was telling that this is our circuit, adder circuit, that can perform both addition and subtraction based on the control command that is given as add and subtract. So as you can see, there are two numbers and it's a basically 4-bit adder. So your given two number is a equals to 0011 and b is your 0010. So we need to perform both addition and subtraction. How can we do that? So in this circuit, if we give add equals to 1 and sub equals to 0 command, then what will happen? This 0 will come here as 0, so the input carry for this 4-bit adder would be 0, and since you have put sub command 0, so for this AND gate the input would be 0, 0 here, 0 here and 0 here. Similarly, if you put add command 1, so for the AND gate 1 3 5 7, one of the input will be 1. Now the number given as A, it will directly come here. So 0 0 1 1, it would come directly here, and the number B given here is 0 0 1 0. So 0 0 1 0 is put here, so the complement of the numbers would be 1 1 0 1. So this 0 will come in this AND gate, this 0 will come in this AND gate, this 1 will come in this AND gate, and this 0 will come in this AND gate. Similarly, this 1 will come this AND gate, this 1 will come here, this 0 will come here, and this 1 will come here. So as you know, for the AND gate, if one of the input is 0, the output of the AND gate would be
0.
0, right? So for these AND gates 2, 4, 6, 8, the output would be 0. Similarly, for the AND gate 7, 0, 1 and 0 and 1 gives you 0. For AND gate 5, 0, 1, 1 gives you 0. For AND gate 3, 1 and 1 gives you 1. And for AND gate 1, 0 and 1 gives you 0. So the summary output of this circuit would be 0. Then 0 plus 0 gives 0. Then 0 plus 1 gives you 1. And 0 plus 0 gives you 0. Can you see this is the exact number what is given as B? 0, 0, 1, 0. You are getting my point, right?
Yes, sir.
So now what this adder would do, they will simply just add the binary bits. So A0 will be added with B0, A1 will be added with B1, A2 will be added with B2, and A3 would be added with B3. So what they will be doing here is that your A is given as 0, 0, 1, 1, and B is given as 0, 0, 1, 0. So the summation would be 1, 0. There would be carry here. So 1, 0. So it gives you 5. Your number was, this number represents decimal 3 and this number represents decimal 2. So the sum should be 5 and it would appear here 0, 1, 0, 1 as output. Is there any question so far? Any question?
No, sir.
Okay, so for the another part, now we need to know how this subtraction is done by this adder circuit. So in that case, we have to put add 0 and sub 1 command. So if you put sub 1 command, this thing, the input of the carry would be 1 because it is directly connected to your sub command. And all of the AND gate of 2, 4, 6, 8 will get
1.
here 1, 1, 1 and 1. Similarly, since add command is 0, so all the AND gate will get 0, 0 and 0 as one of the inputs. So what was my number? This two number is the same as it is that it was previously. So 0, 0, 1, 0 and B is
0, 0.
0, 1, 0. So this represents decimal 3, this represents decimal 2. So if we subtract, what should I get? I should get 1, right?
Yes, sir.
Which should be 0, 0, 0 and 1.
1.
So how can we do that? First, what we need to do is to keep the number A as it is. So our number would be 0, 0, 1, 1 as it is. Then the number that needs to be subtracted, we have to take the ones complement of that number. So what will be the ones complement of B? Ones complement of B would be 1, 1, 0, 1. That is the ones complement of,
B.
right? And then in order to get the twos complement of this B, we need to add 1 with it. So these three terms, if we add them, then we'll get the subtraction result. So how can we do that? 1 plus 1 gives you 1, 0, and then again 1 gives you 1. So carry would be here. 1 plus 1 gives you 0. Again carry here. So 1 plus 1 again gives you 0. Then carry would be here. 1 plus 1 gives you 0. And there should be a carry here. So if you neglect this thing, The rest of the 4 represents what?
1.
1, right? So similarly, in this circuit as previously described, A will be given as it is 0 0 1 1, exactly same as A. So here A comes directly. Now what we need to do, we need to, in order to get the subtraction result, we have to add them together, but after converting the B number into its equivalent 2's complement. So how we can do that? So now previously we said 0 0 1 0, this is my actual number, so the complement of this number would be 1 1 0 1. So this 0 will come here, this 0 will come here, this 1 will come here, and this 0 will come here. So as you know, the input, if one of the input of a AND gate is 0, the overall output of the AND gate would be 0. So the output of AND gate 1 3 5 7 would be 0, since one of its input is 0, right?
Yes, sir.
Similarly, this one will come here, this one will again come here, 0 will come here, and 1 will come here. So the output of the AND gate 2 4 6 8, what will be the output? 1 and 1 gives you 1, 1 and 1 gives you 1, 0 and 1 gives you 0, 1 and 1 gives you 1. So thus if you make the sum of it, 1 plus 0 gives you 1, 1 plus 0 gives you 1, 1 plus 0 gives you 0, 1 plus 0 gives you, sorry, 1. 1. So as you can see, this 1101 is exactly this number, right?
Yes, sir.
So this is what? 1's
Complement B.
complement of B, right?
Yes,
And
sir.
if you give subcommand 1, this 1 will come here. So this is the 1 that needs to be added with this number, right? So you are getting this number and you are providing 1 as carry, and this number comes as it is. So this adder will do what? The summation of these 3 numbers, right? Right?
Yes, sir.
Yes, sir.
So what will be the output here now? It should be 0 0 0,
0,
and the carry bit here, it should be
1.
so whenever your carry bit is 1, you need to remember that this is doing subtraction, and for this part your carry bit was
0.
right.
Yes, sir.
So this summer circuit, actually based on our control command, we can do either addition or subtraction. Is there any question so far?
No, sir. No, sir.
So this is another adder circuit that can perform both addition and subtraction, but this configuration is different from what we have learned in the previous 2 slides. So what is happening here? So what is happening here? Um, we are using a exclusive OR gate to get the number B. So do you remember what was the truth table for exclusive OR gate?
Yes, sir.
X and Y, your output should be X bar Y plus X Y bar, right?
Yes, sir.
The combination would be 0 0 0 1 1 0 and 1 1. So the output would be 0 when you have the same input, and when you have different input, the output would be 1, right?
Yes,
Yes, sir.
sir.
So now I am taking a simple example, like we are taking a as, you just give me two numbers.
5.
5, 1 is 5, okay? 0 1 0 1, that is 5. Another number,
3.
0 0 1 1, that is 3. So now if we need to add them together, then what we have to do, suppose a is my number 0 1 0 1 and b is another number 0 0 1 1. So if we add them, what I should get? 0,
8.
carry will come here, again 0, this carry will come here, again 0, and then it should be 1, right? This gives you 8, right?
Yes, sir.
Yes, sir.
Okay, so now we'll control the addition and subtraction by this control command m. So if I give m equals to 0, that's mean one of the inputs of this exclusive OR gate would be 0, and since it is 0, this carry of the first full adder would be 0. So what is my number right now? It should be 0 1 0 1. So it should be 0 1 0 1. And what is our other number? 0 0 1 0. So it should be 0 0 1 0 0 1 1. 1 1. So this 0 will come here, this 0 will come here, this 1 will come here, and this 1 will come here. So this A3 will come here 0, this 1 will come here, this 0 will come here, and this 1 will come here. So now what should be the output of this exclusive OR gate? Two inputs are same, so output
0.
should, two inputs are same, so output should be 0. Two inputs are different, so output should be 1. And two inputs are different, so output should be 1. So this 0 0 1 1 gives you the exact number of this B, right?
Yes, sir.
So then what would be my outcome? So for this first order, 1 plus 1 gives you
0.
sum 0 and carry 1, right? So this sum would be 0 and carry would be 1. Again, 1 plus 1 gives you sum 0 and this carry would be 1. Again, 1 0 plus 1 gives you 1, 1 plus 1 gives you sum 0 and carry 1. And 0 plus 0 and then again 0 plus 1 gives you sum 1 and carry 0.
0. Yes, sir.
So whatever you got here, that should be my S3, that should be my S2, that should be my S1, and that should be my S0, right? And since there is no carry, this should be my C4, which is here, right?
Yes, sir.
Yes, sir.
So this thing, by giving control command 0, we can add two numbers. Now whatever happens when we put the control command as 1, let's see. So now what I am doing here, I will just change the control command here, and see what happens. So our number would be the same, just we are changing the control command to 1. So this one will come as the input, carry 1 for the first adder, and since this is 1, all the exclusive OR gate input would be 1, and this 0 will come as it is. So this is my A. Now what will happen to B? So 0 plus 1
1.
gives you 1, 0 plus 1 gives you 1, 1 1 gives you 0, 1 1 gives you 0. So 1 1 0 0, this is, if your B is 0 0 1 1, so what is, if I need to subtract, what I have to do?
To take
A should be as it is, 0 1 0 1. Then what I have to do? I have to take the 1
one's complement
complement
of
of B,
2.
right?
Yes, sir.
What would be the 1's complement of B? 1 1
0 0.
0 0, right? And then I need to add 1 with it so that I get the result. So now this 1 1 0 0, can you see this 1 1 0 0? This is the 1's complement of the number, right?
Yes, sir.
Yes, sir.
And this input bit, this is coming as a carry. So as you can see, this thing, this addition is done in here, right? Right?
Yes, sir.
So what should be your outcome here? 1 plus 1 gives you 0. It should have a carry here. Then again 1. Then
0.
plus 1 gives you 0. And then again 1. 1 plus 1 gives you 0. And then the carry should be 1, right?
Yes, sir.
If you take this 4 value, so it should give you 2, right? And this should come as C4. This should be your S3. This should be your S2. This should be your S1. And this should be your S0, right? So let's see what happens. 0 plus 1 gives you sum 0, carry 1, right?
Yes, sir.
0 and then 1 gives you sum 1 and carry 0. 1 plus 0 gives you sum 0 and carry 1. 1 plus 1 again gives you sum 0 and carry 1. So these two calculation complies with one another, right?
Yes, sir.
Is there any confusion that need clarification, or is there any question so far?
No, sir.
Okay, so if you don't have any question, so in the practical circuit in the computer, you might see this kind of chip that can perform several operation based on the control command given in this command bit. So there are 3 inputs here. So how many combination it can get?
8.
So if you put 2 numbers, 4-bit numbers A and B, based on the control command given in S, you can perform different operations, such as if you give 0 0 0, it will clear the memory. If you give the control command 0 0 1, it will do B minus A. If you do 0 1 0, it will do A minus B. If you give control command 0 1 1, so if you give 0 1 1 here, what they will do, they will add A plus B. Then again if you do 1 0 0, then they will do exclusive OR of A and B. Then if you do 1 0 1, they will do the OR operation. If you give 1 1 0, they will do AND operation, and similar to that, based on the control command given in this 3 input, you can perform the operation based on your choice. Is there any question here? So that's why it is called ALU, arithmetic logic unit. Any question?
No, sir.
Okay. So now we can go for a different type of addition, which is called BCD addition. What is BCD addition? What BCD refers? You remember?
Binary
Coded
coded decimal.
decimal.
Coded decimal, right? So what was that? We said every decimal digit is represented by its 4-bit binary
Binary coded decimal.
digit, right?
Yes, sir.
Yes, sir.
So for the first two operation, let's see what they are doing. So suppose we have 0011, so it gives 3, right?
Yes,
Decimal.
sir.
And then 0100, it gives you 4,
Oh,
right?
yes.
So if you add them together, what you get? 1110. It is 7, right?
Yes, sir.
So the BCD addition, if you do the binary addition, you will get the BCD addition once the sum is less than 9. If the sum is less than 9, you just do the normal addition, binary addition, and you will get the BCD addition. But the problem arises when the sum goes above 9. What is a problem with that? For BCD, if you have 10, what is the binary number of that? 1010, right? And what is the BCD code for that? 0001 for 1, and this 0
40.
by 4 zeros, right? So the BCD and binary will not work if
After
number is beyond
greater than 9.
9. You got my point, right?
Yes, sir.
Yes, sir.
So let's see what is happening here. So B, it says 0010 and then 0011. So what's the number? 2, 3, right? These 4 represents 2, these 4 represents 3, right?
Yes,
Yes,
sir.
sir.
Again 0001 and 0101 gives you 1 and 5, right?
Yes,
Yes,
sir.
sir.
So what should be its outcome if you do the addition? 838, right?
Yes, sir.
So if you add them together, 1 plus 1 gives you 0. 1 should come here. 1 plus 1 gives you 0. The 1 should come here. 1 plus 1 gives you 0. This 1 comes here and it gives 1. Then again 1, 1 plus 0, 1, 0, 0. So these 4 bits represents 3. These 4 bits represents 8. So this gives 38, right? So you remember this 3 plus 5 gives you 8, which is less than 9. This 2 plus 1 gives you 3, which is also less than 9. So whenever the summation of two numbers is less than 9, you just do the simple addition, binary addition, and you will get the result for BCD. You understanding my point, right?
Yes, sir.
Now let me do some problems where the summation goes beyond 9. So suppose we have one number 47 and we have another number like 15. So how can we write 47? 0 1 0 0 for 4, and 7 should be 0 1 1 1, right?
Yes, sir.
Again for 15, how can we write that? 0
0, 0, 0, 1,
and 5 should be
0,
0
1, 0, 1.
1, right? So now if you add them together, so what will happen? This should give you 62, right?
Yes, sir.
So 1 plus 1 gives you 0, carries come here. 1 plus 1 again gives you 0, carries comes here. 1 plus 1 gives you 1, carry is 1, and then again it should be 1, and then 1 0 1 0. So these 4 bits represents what?
5,
5.
5, and these 4 bits
12.
12, which is greater than 9, right?
Yes, sir.
Yes, sir.
So whenever your sum goes beyond 9, what we need to do, we just need to add 6 with it. You may ask why we are adding 6, right? This question comes. So if you have a 4 bit, how many numbers you can have? 16, right? 0 to 15.
Yes, sir.
For BCD, the number we have is from 0 to 9, right?
Yes, sir.
We don't have 10, 11, 12, 13, 14, and 15. These are the 6 numbers that is missing in BCD. So that's why whenever the number goes beyond 9, like 10, 11, 12, 13, 14, 15, we need to add 6
6.
with the number to get the exact result. So now if you add 6 with it, what we will get? 0, 1, 1 plus 1 gives you 0, and the carry 1 with this one again gives you 0. So this carry will come here. So 1 plus 1 gives you 0, carry comes here, again 1 1 0. So now this represents what? 6. This represents
2.
2. This is the result, right?
Yes, sir.
Are you getting my point?
Yes, sir.
Yes, sir.
Yes, sir.
So let me do another example. Suppose you are adding 67 with 45. So what should be the
112.
BCD number? It should be 0 1 1 0 and 0 1 1 1, right? And 45 0 1 0 0 and then 0 1 0 1. So if we add them together, what I get? 1 plus 1 gives you 0. This one comes here. 1 plus 1 again gives you 0. This one comes here. 1 plus 1 plus 1 gives you 1. Carry comes here. This one comes here. Again 1 0 plus 0 gives you 0. 1 comes here. 1 plus 1 gives you 0. This carry comes here. And then this is your number. So what does it represents?
10.
10, and this is 12.
12.
So both are greater
Above
than
9.
9, right?
Yes, sir.
So what we have to do?
Plus
We have
6.
At 6.
0 1 1 0 here, and again we have to add 0 1 1 0 here to get the exact result. So now what I get? 0 1 0 0, then again this ones comes here, 1 0 0 0, then 1. So what should be your outcome? 12,
112.
1 here,
112.
112, right?
Yes, sir.
So if you add 3 zeros in the front to make a 4-bit binary, so it gives you 1, also gives you 1, and this gives you
2.
2, which is this result, right?
Yes, sir.
Yes, sir.
So now we'll design a BCD adder. So before we do the circuit design, we just need to know the truth table. So as you know, from 0 to 9 there is no difference between the BCD and the binary number, right?
Yes, sir.
Yes, sir.
But the problem arises when the number is above
9.
9. So they represent a 5-bit number, because you can have a carry here as well. So if you have 5-bit, what would be the combination? 0 to 31, right?
Yes, sir.
But here they are only showing 0 to 19. Why is that? Can anyone tell? So what is the single maximum bit that you can have for BCD? 9, right?
Yes, sir.
So the maximum you can add is 9 plus 9, right?
Yes, sir.
And if you have a carry from the previous bit, the total sum can be 9,
19.
right? So you are understanding why they are taking 0 to 19, right?
Yes, sir.
Because the maximum decimal bit that can appear is 19. Is there any question?
No, sir.
So as you can see, for 10, how can we write the BCD? We can write 0001, then
4 zeros.
000. So you neglect these 3, and if you consider this 5 thing, this should be your number, right?
Yes, sir.
And for the binary number, what is the value of 10? 1010. So they put 1010 here, and they put a 0 in front to say the carry. Similarly, you can write all the numbers represented in the binary form and the BCD form, right?
Yes, sir.
So now if I need to design a circuit for which we need to add, whenever the number is goes beyond 9, what we need to do?
To add 6.
We need to add 6, right?
Yes, sir.
So how can we do that? Let's see how they are doing that. So here you can see it's a simple 4-bit binary number adder, and which adds everything as we have learned so far, simple binary addition. But the circuit represents here is the circuit for the BCD addition. This circuit will decide whether I need to add 6 or 0 with the number. You are getting my point, right?
Yes, sir.
So suppose we have a single bit number, uh, A and B. So give me any number.
7, sir.
A7. Okay. So what will be the binary form of it? 0 1 1 1. And any other number? Any other number?
9
Okay, 9. So 9 is given by 1,
0
0,
0 1.
1. Right?
Yes, sir.
So now if you add them together, what will happen? So if you add them, the addition should be 1 plus 1 gives you 0. Again 1 comes here, so it is also 0. Then 1 comes here, it is also 0. Then 1 comes here, this is also 0, and this 1 comes here, right? Did it right?
Yes, sir.
So if you put these two numbers here, 0, 1, 1, 1, which gives you 7,
7.
and if you put 9 here, 1, 0, 0, 1, the output of this circuit would be these 4 bits, 0,
0,
0, 0,
0. Carry
and the carry should be
1.
1, right?
Yes, sir.
So these 4 numbers will come here as it is, 0, 0, 0, 0. Then what will happen? So now here you can see this one comes here as 1. This AND gate input is between these two terminals, so this gives you 0 and 0. The output of this AND gate would be 0. Again the input in gate input is 0 and 0, so the output of this AND gate would be 0.
0.
So if you sum them together, the summer output here should be
1.
right.
Yes, sir.
So now here you can see here it has a special connection here, and I will explain you why the connection looks like this. So for the BCD addition, you either have to add nothing, or if the number goes beyond 9, you have to add
6.
right.
Yes, sir.
So nothing means what? 0, right?
Yes, sir.
And 6 is what? So for these two number, as you can see, the most significant bit and the less significant bit are same, right?
Yes, sir.
And which is 0. So here what they have done, they have already put these two inputs as 0, and the middle two inputs, it comes from this circuit. So if this circuit output is 1, it means 1 will come here, 1 will come here. So the number will be added here 6, right?
Yes, sir.
You are understanding my point, right?
Yes,
Yes,
sir.
sir.
So what will happen here? So they will do 0, 0, 0, 0, and then they will add what? They will add
0110.
0, 1, 1,
0.
0. So what will be the sum?
0.
0110.
110.
0. So it should be
6.
right.
Yes, sir.
So if you add 0, 1, 1, 0 with it, so what will be the outcome? So if you add 3 zeros and the font, so it should be 1
1.
and
6.
6, right?
Yes, sir.
So the summer output here, it should be
16.
6, right? Are you getting my point?
Yes, sir.
So now, and the carry comes here, right? So the carry is 1 here, that is going out. So now tell me one number whose addition gives you less than 9. Tell me one number.
2 and 5.
Okay. So 2 and 5. So now if you have 2 and 5, so 2 is represented by 0, 0, 1, 0, and 5 is 0, 1, 0, 1. So if you add them together, it should be 1, 1, 1, 0, which gives you directly 7, right?
Yes, sir.
So now if you put 2 here and 5 here, so 2 should be 0, 0, 1, 0 here, and 5 should be 0, 1, 0, 1 here. So the addition would be 0, 1, 1, 1, right?
Yes, sir.
And carry here it should be
0,
0. So this 0 comes here, this and this input it should be 0 and 1, so the output would be
0,
0. Again this is 0 and this is 1, so the output of this AND gate would be
0.
0,
so the carry out would be
0.
0,
0. And since this term, these two terms are 0 and 0 is coming out here, so this term should be 0 and 0, right?
Yes,
yes,
sir.
sir.
This number is coming directly here, so 0, 1, 1, 1. So the addition would be 0, 1, 1, 1 with
0,
0, 0,
0, 0,
0, gives you the same number, right?
7. Yes, sir.
So you are understanding how these things,
Yes, sir.
right?
Yes, sir.
So now let us see how this circuit is designed. So this circuit will only operate whenever this carry out becomes what,
1.
right? Right?
Yes,
Yes,
sir.
sir.
So how can you get the carry out 1?
When we add
When
the
we
So
pass 9.
you can, if you see here, from 10 to 9 this output is 1, right?
yes, sir.
Yes, sir.
So we have to look for the combination for which the output is 1. So we can choose all the combination from 10 to 19, right?
Yes, sir.
So among them, if you see from 16 to 19, one combination is common for which the output will be 1. What is that? Your K is
1.
1, right?
Yes, sir.
So we can say if your number is from 16 to 19, the output would be 1 if only your K is 1, right? Right?
Yes,
Yes, sir.
sir.
Or for number 10 to 15, what will happen? For number 10 to 15, what will happen? Can we see another combination? Yes.
Yes,
Is
it B.
that?
Z is 8 is 1, right?
Yes, sir.
Yes.
Z8 equals to 1. And one thing you can see, either this Z2 is 1 or Z4 is 1 or both of them is 1, right?
Yes, sir.
So you can write either Z2 is 1 or Z4 is 1, right?
Yes, sir.
So in terms of equation, if we try to write f, so what we can write? K plus
A
Z8 multiplied by, since
Z2
this is and, so
plus
you can write Z2 plus
Z4.
Z4, right?
Yes, sir.
Which gives you this circuit. Is there any question? No question means you are understanding anything or understanding nothing. So if you don't have any question, you are good to go.